Welcome. Today we're going to be talking about secrets, and in particular, I say cloudy world. I just hate that expression. This is the last time I'm going to say the word cloud. Not only is it, I think, ambiguous, but also I think it's just kind of lame. So from now on, I'm going to just use the word AWS because that's how at Yelp, in particular, we use AWS. So I'm going to be using AWS-specific terminology. Again, just to be more precise, this is an engineering talk here. And also just because I hate the expression cloud. If you haven't heard of Yelp, Yelp is a company that builds a mobile app and a website to help you find and connect to great local businesses. For example, after PuppetConf, you might use Yelp to find a nice bar to hang out with or a nice restaurant to get some food, or maybe your next doctor appointment, that kind of thing. I'd like to lay out some assumptions. When you're talking about security, you have to frame what exactly you're talking about because there's so many different dimensions of talking about security and how you're going to secure things. So let's go over some of these assumptions. When I say a cloudy world, I really mean a world where we can launch servers and they can come and go, and that there's no human intervention required to secure them. I think this is a big sticking point. If you look at many security products that depend on a core piece of bootstrapping secret that a human has to synchronize to it, all of these I consider to be not acceptable for a cloudy environment where we autoscale. So that's what I really mean by cloudy. I also assume you're using a mono version of Puppet. At Yelp, we happen to not use Puppet Enterprise. It doesn't really matter for this talk. And whenever you see the word environment in my presentation, you can replace it with your own kind of company-specific version of this. For Yelp, this means dev and prod. It might be something like that. At your company, there might be a more protected credit card environment versus the web frontier. Just imagine that as what I mean when I say environment. I also, for the purpose of this talk, I'm assuming that we can manually bootstrap puppetmasters. Now, in a world where we are really high scale, maybe this isn't a fair assumption, but for at least at Yelp, we don't auto-scale our puppetmasters yet. So for the purpose of security, I consider it okay if we have to manually bootstrap the security of a puppetmaster. But before we go any further, let's talk about why we're here. Because I think it's really important from an engineering perspective that we also consider the business impact of what we're doing. We're not securing these servers for security's sake. I don't work for the security team, yet I consider securing my servers as a very core competency of my job. But in the end, we're doing this to empower business. So a big value to the business is being able to autoscale. Scale up our servers up and down according to load. But I want to mitigate the risk of those servers being compromised and extracting all the secrets away. So I'm trying to balance the business needs with the security risk and that sort of thing. If we were super security conscious, maybe we wouldn't have such a dynamic environment. It would all be static, and we could make really strong assertions about the security of our environment. But for the business, we need to be able to scale dynamically. So that's really why I'm up here talking to you today, is because this is a business need. But it is really about balance. And let's talk a little bit more about that. Take a look at this matrix. Maybe soak it up a little bit. Again, when you're talking security, you have to frame the question. You have to frame the discussion. What does this secure? What does this not secure? No security implementation is perfectly bulletproof. And maybe a particular problem that a security product can solve doesn't even cover a different type of situation, say a root shell on a client. And for this discussion, a client means a public client. So I encourage you to take this kind of matrix. When you go back to your individual companies and you're having a security discussion or you're evaluating a security product, take a matrix like this and put in your own columns. Maybe there needs to be a column called credit card environment if you handle credit cards. Maybe there needs to be a column or a row called web server getting hacked with a PHP exploit, something like that. Put in company-specific rows and columns so that when you evaluate a product, you can say with clarity, oh yeah, if we deployed product X, it doesn't protect us against a web server getting hacked, but it does protect us against the credit card environment being exfiltrated. Maybe you're evaluating firewall rules and that sort of stuff. I think it's really important to just be explicit and clear about what this does and does not do. And we'll use this rubric to evaluate certain things here. So, classic Puppet. When you deploy Puppet for the first time, maybe it's the first time you've ever used Puppet ever, you almost certainly turn on naive autosigning. Naive autosigning is where the Puppet master will sign the certificate that comes out of Puppet agent with its CA, and then from then on, communication is over SSL, it's encrypted, that kind of stuff. You might skip past, if you're just doing the proof of concept, the security implications of autosigning. Of course, you should never do this in a production environment. It doesn't really say why. Why shouldn't you do this in a production environment? But also, like many things, at least at Yelp, things kind of turn from proof of concept to production pretty quickly, and there may be, somebody may have just skipped over this. So before you know it, you may have a very large fleet of auto-signed Puppet agents. There are no cameras on the audience, but is there anybody who would admit that they use auto-signing at their, yeah. Well, my hand goes up too, because until relatively recently, Yelp also auto-signed. Because, again, being in a cloud environment, it's not exactly easy and straightforward how you should not do auto-signing. And there's a new server coming up, and it's because an autoscaling group launched it. Does that mean that a human needs to be woken up in the middle of the night to be able to run Puppet cert sign? Let's look at a classic Puppet example, and then we'll think about Puppet auto-signing. We'll look at our rubric. We'll try to evaluate this together. Take a look at this classic kind of Puppet secret environment. We're using Hira, like good Puppet citizens. It's not actually in the code itself, although for the sake of this example, Hira is just in a Hira folder in the Puppet repo. Classic stuff, don't worry about it too much. It's just a plain old template. If we have Puppet auto-signing enabled and we're using that, what exactly are we protecting against? Or what do we not protect against? Well, let's look at the rubric together. Well, as long as our Puppet masters are secured from the internet, which we absolutely should have, we're golden. Good. Well, what about if an attacker got inside the network? Would they be able to get our secrets out? The answer is yes, because Puppet would kind of just sign any certificate that you fed it to the Puppet masters, so you could just make up your own host name and say Puppet agent cert name equals web server, and it would gladly sign that and then hopefully deploy the secrets to you. And it kind of goes all the way down. If you looked at the Puppet repo code, of course the secret's in there in plain text in the YAML. And of course, if you got on a Puppet master, the files would just be there unencrypted. So it doesn't really protect against much. So this is the why. This is the why you shouldn't have auto-signing enabled on your Puppet masters. Because without that strong guarantee about who is talking to your Puppet masters, you can't really have any faith that anything is secure. Because there's no validation on the client. We're not authorizing the client in any way or authenticating them. I don't need to talk too much about the difference there, but we're not authenticating or authorizing the clients with Puppet auto-signing. And of course, there's no encryption. The content is in plain text on disk on the Puppet masters. So can we do a little better? So this is Yelp's first attempt at trying to do a much better job at this. What we did is we encrypted the secrets using a symmetric key, and we manually deployed that decryption key onto our agents. This decryption key isn't the secret itself, it's used to decrypt subsequent secrets. And then we put the encrypted versions of the secrets that we actually want in Puppet itself, and then we use an exec to decrypt those files at Puppet apply time on the client. It's similar to this linked GitHub Puppet module here. The idea here is that it's the client that decrypts the Puppet secrets, not the Puppet master. So even though we don't really trust the Puppet master to hand out secrets in any sane way, we can have faith that this manually deployed decryption key is only on the hosts that really need it. Are we doing better? Well, yeah, we're doing a lot better here. Getting access to the Puppet repo doesn't do anything. The secrets are encrypted using that strong key, so you don't have that key. Getting shell access to the Puppet master doesn't help you either, because it's the clients that decrypt the secrets, so that's good. Shell access to a client doesn't really help you much either, because in this scheme, the actual decryption key and secrets are owned by root, so that doesn't help. Root shell access on a client is a little iffy because if you got root shell access, you would be able to read that decryption key and subsequently read any secrets that were encrypted with it. But again, it's all about framing the security discussion here. Don't let that red bar at the bottom dissuade you from increasing your security posture on your infrastructure. I think, and security especially, perfect is the enemy of the good, if you've never heard that expression. It means, if you've never heard that expression, it means that it's really easy, the enemy is thinking that you'll be able to find a perfect security implementation of some sort of thing. You may never be able to get all the way down to the red. You may have to just assume that if somebody gets root on a web server, they'll have the root web server secrets. Maybe with some SE Linux mumbo jumbo, you could mitigate that. But for the purpose of this talk, this is the state of the world with client decrypted secrets. But there's one big problem here. It doesn't satisfy one of my first assumptions, that we need to be able to launch these nodes in AWS with no human intervention. How are we going to do that if in order to have a secure piece of infrastructure, we have to manually deploy this secret on disk? That's the problem. But Kyle, I encrypt all the things. So in newer versions of Puppet, EYAML is kind of like it's baked in, although you still need to install the gem. But this is currently the state of the art about encrypting secrets in Hira EYAML. Pretty good. You should absolutely use the trusted facts construct to be able to look these up. If you're not aware, trusted facts are facts that come out of the Puppet certificate. They can't be spoofed. Unlike other facts where you can kind of just say your environment is production just because you give that up to the puppet master. The trusted facts come from the certificate, and they're kind of evaluated by the puppet master itself, not by the client. But look at the parentheses. We're still using autosigning. So what would it look like if you had implemented EYAML, encrypted, you secured your puppet masters, and you got the decryption key on the puppet masters, but you're still using autosigning? What would the matrix look like? Well, it's not that great. Sure, we've protected the code repo itself. So we've gotten the secrets encrypted on disk in the code repo. So developers can't see the raw thing, and neither can attackers. That's good. But everything else is still red. Why is it still red? Well, everything else is kind of still red because we're still autosigning. If you're autosigning, then you can just ask Puppet for a certificate, claim your host name to be whatever you want, and Puppet, again, will gladly deploy those secrets to you in a decrypted form. Because Puppet Master, of course, the Puppet Master has them in decrypted form, and Puppet's job is deploying files to you. And if you're a web server, you get this file. You might be able to do a little better by segregating off secrets from different environments. You could only deploy the credit card secrets to the credit card Puppet Masters. But for the most part, you're still kind of bound by the weakest link, which is the auto-signing thing. So can we do better? Again, the reason this is still red is because we can't trust that our clients are who they say they are. Even simply just accessing the network itself, you can just run Puppet Agent. And you don't have to be root to run Puppet Agent. You can just run Puppet Agent --cert_name = web server. So we must validate our certificates, but how do we do that? Well, the docs say that you can use the web interface for Puppet Enterprise. You select all the nodes, and then you click accept all, reject all, or do something like that. Or if you're using good old Puppet open source, you can run Puppet cert sign. The key problem with this in a cloudy environment, again in AWS where you might have an auto-scaling group, is a human's not going to run this. Can we automate it? Can we automate this in a way that we can have faith that it's actually secure? Well, let's read the white paper. Puppet provides a white paper on AWS lifecycle management, and it goes all through the kind of like how you might do this. It even comes with a Puppet code repo with some example code. Let's take a look at it. So if we do that, let's say we took the code as is from this white paper and applied it, would we be any better? Well, I'm sad to say that we're only marginally better because the code as written is just an example code. It doesn't actually do strong verification. What's up with that? The reason that this is the case is because the example code in that repo doesn't doesn't actually make, again, it doesn't make strong assertions that the EC2 instance that is talking to the puppet master is actually legit. There's nothing stopping somebody from, the autosigner from signing an arbitrary certificate with any arbitrary cert name. And the code repo is at least honest about this. They say that this is just an example for how to get started. But to me, it's just not enough. It's just not enough that this is the case, that the example from Puppet is just insufficient. Can we do better? Well, I posit that we can. I think we can do better by making the autosigning script, the script that comes out of that repo, make a really strong assertion about the cert that it's coming from. The docs kind of hint that you could do even better by putting in a secret, like an initial secret that only the Puppet agent will know at boot time, maybe. But no matter what we do, as long as we can make it so that the auto-signing script, that the equivalent of the thing that's running Puppet sign, whatever, never does this for an unauthorized client, then I think we'll be golden. Could we? Well, let's read the docs a little bit. Don't worry about all this text, but it does say that if you embed a unique pre-shared key on each node when you provision it and provide a policy X, blah, 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 blah. Well, okay, I think we might be able to come up with a scheme like this. All right, fine. If nodes are running a cloud service provider, well, yeah, we could probably like make a script that checks the instance ID, something. But let's look at this last thing. As you can see, you must think things through carefully when designing your CSR data and signing policy. As long as you can arrange reasonable end-to-end security for your secret data on your nodes, you should be able to rig up a secure auto-signing system. How do people feel when they read that block of text? Is chuckling? Is like laughing? I also felt kind of strange when I read that. I was like, what do you mean I can probably rig up a secure auto-signing system? Like, I personally find this unacceptable. And I'd like to kind of make a call for Puppet Labs employees maybe to like up their game on this, because I understand why they do it. They can't be held responsible for recommending a particular security thing. It's like, oh, that's not enough for my credit cards. We were just following the docs. But I think we can do better. I'm sad to say that at Yelp, our particular implementation is not open source, but I'd like to see if I can work towards making that happen to establish kind of like a reference design, maybe. But I think in the end, it's going to be Puppet who's going to have to lead the charge for securing Puppet masters in AWS, other clouds, in a really hardcore manner, much more than the kind of proof of concept, here's a script to maybe get you going, that doesn't actually provide any strong security. But let's say we did it. Let's say that we work really hard and we came up with an auto-signing script that was pretty bulletproof. And to put it in the docs terms, we rigged up something that did a good job. Would we be in a better position? The answer is yes, but we need to be really careful about what it is that we're protecting. If we got the auto-signing correct, are we protecting against puppet masters being hacked? Well, no, because again, puppet masters have the decrypted versions of the EMLs on disk. So if you had root or puppet access on a puppet master, they would be vulnerable. Maybe that's acceptable, maybe it's not. On a client, if they have shell access, that's probably not enough. I put it in gray because it kind of depends on exactly how you share that initial secret in the AWS user data. You have to remember that in Amazon, the way that you extract user data and instance profile keys all come from the host local IP of 169.254.something. Any process on the box can get at those credentials. Like, you don't have to be root to be able to curl 169.1.254. That's often forgot. Then we kind of, Amazon is kind of like taking for granted that every EC2 instance is single purpose, and you would never have something that was, non-privileged running on that box, privileged from a security perspective. Again, root shell client access will only be able to decrypt the secrets that it's supposed to have, but I think we can do better because the auto-signing thing can refuse to sign a certificate where the environment doesn't match, and maybe you could make a mapping between what environment the host was launched and say, no, I'm not going to sign a prod cert because you're not in prod. You could probably do that, and that would protect the environmental secrets from bleeding. I think that would be pretty strong. So this is where Yelp is right now. We've got pretty good auto signing, and we're pretty confident that Puppet is only giving away certificates where it should be. and we have faith that the encrypted versions in our Puppet code are legit and won't be leaked. We accept the fact that if somebody hacked the Puppet Masters, they will be able to get the secrets on disk. Again, it's all about framing the conversation and doing better, getting incrementally better. Even though it's not perfect, we're getting there. But can we do better? So, So what does this give us? It really, in the end, it gives us confidence that the trusted facts that are reported by Puppet are legit. Again, if anything outside the trusted facts can be spoofed, but the trusted facts hash comes from the certificate itself. So whatever we built into the auto-signing script as signing, as verifying, we can verify that's the case. So if your auto-signing script is verifying the role, say, from the Puppet tag for a server, you can have faith that trusted bracket role is true and legit and not spoofed. Likewise, with the host name or any other thing that you're asserting in the Puppet auto-signing thing. Again, the Puppet auto-signing script that comes from the AWS lifecycle repo is kind of bogus. It doesn't do anything strong at least. So what it does give you is all about how rigged up your auto-signing script is. But can we do more? I think we can. So at Yelp, we've decided to invest in Vault from HashiCorp. If you've ever attended any kind of secret thingy, this kind of comes up eventually. Vault is by no means a kind of drop-in turnkey security solution. It is absolutely a low-level tool for, and I stand by the fact that I say it's low-level. It is a toolkit for you to use. It is not something that it will integrate Puppet with Puppet nicely. Although, again, I look forward to open sourcing what we've done with Vault, our Puppet integration. Maybe that's one of the hardest things open source. But what would this look like? At Yelp, we've got our Vault infrastructure pretty solid. How are we going to integrate it with Puppet in a sane way? Well, with Puppet clients, if they're going to be the things talking to Vault, they need a token. So how are they going to get that in a secure way? So we have to answer that question. If we allow our Puppet servers to talk to Vault, that means that they have keys to the kingdom. Could we reduce our security footprint by not allowing the Puppet servers to need to talk to Vault at all? Because if we could, that would fill out, that would eliminate one of the lines and turn it from red to green, so rows. And I'm paranoid about Vault going down and putting it in the critical security path, the critical path of our servers booting and bootstrapping. That means if Vault goes down, we can't like launch new servers, auto-scaling halts. That would be bad. So if possible, it'd be nice if when Vault goes down, nothing bad happens. Can we architect a system like that? Well, let me tell you about how we're planning to do it. This is not rolled out in the prod yet, just full disclosure, but right now, our Puppet Masters can talk to Vault. We use the AWS IAM auth backend. I'll talk about that next. We cache every secret and we just cache it on disk, root readable only, to make it immune from Vault outages. So any new secrets are just, we can't get new secrets, of course. That's an acceptable failure scenario. And then we use Puppet functions to extract them. We use the secret keyword to make sure that they don't show up in diffs and stuff. The bonus here is that in the future, we're going to be able to use Vault for other things. And I think this is really important for those architects or engineers who are building things and thinking to themselves, well, yeah, we built something for Puppet, but it's also useful for these other things. It will be a bigger ROI, if you want to think of it that way, for deploying Vault in a sane way. I want to speak a little bit about this Amazon auth thing. I think it's just the coolest. It's a API specifically that seemed like Vault, HashiCorp kind of convinced Amazon to implement it for Vault. But the way it works is when you ask for the identity for a server, that 169.254 curling, Amazon will sign that using their private key. Then the Amazon EC2 instance can talk back to Vault and present this identity and the signature from Amazon. And Vault verifies that against Amazon's public keys. The public keys are just like in the docs. They're just like printed there. I'm assuming that they're just not going to change them anytime soon. But this is really strong. This is a really strong way to be really sure that the thing that's talking to you really is an EC2 instance and it has these attributes and these tags and stuff. No other kind of secret zero or bootstrapping mechanism that I've seen in any security product is as safe as this is Amazon specific. It's Amazon specific, unfortunately. There's no equivalent to this in Azure or GCP. But If you ask me, this is super strong, and on my next iteration of our Puppet auto-signing doohickey, I'm definitely going to use this as the way of verifying that the EC2 metadata that the Puppet agent is presenting is in fact legit. If we did this, the chart doesn't actually change that much. Now, why is that? Well, in this case, because we're still using Puppet to do all of the Vault interactions, which is good. We're centralizing the complexity of managing Vault. We can cache things in a sane way. We don't have to instrument our apps to talk to Vault. Good. But it still puts the Puppet Master at risk. Maybe not so much for the all secrets part, because you're not going to be deploying one single Vault for all your secrets. So there's a little bit more protection, whereas it's more likely you might deploy a single package of Puppet code that might have all your environment secrets. With Vault, it seems less likely you'd do that because it's more like a database. So the chart doesn't change so much. Our next approach, at Yelp, we happen to use Apache Mesos to deploy our applications. And because that's kind of the source of truth about what is being deployed, we think that that's probably the best place to be injecting the secrets, because it's at that point where we can have a lot of confidence about what it is that we're launching. Think about this, the tell, don't ask approach from Ruby. We're telling Mesos what to launch, and we can tell it what secrets to include. If we did it the other way around, we would have to make up a thing where we have to ask a Mesos agent, hey, what are you running? We have to ask it, hey, what are you running and what secrets go with it? The tell, don't ask approach allows you to have a little bit more confidence and build things kind of more secure by design by injecting the secrets exactly when you know what service needs what. We're planning on using console template. Contrary to the name, console template can extract data from console or Vault to deploy the secrets into files on disk. What this gives us the ability to do is to be resilient against Vault failures. The file doesn't go away when Vault goes down. Also, it means the rotation of secrets is now out of band of Puppet. I think this is a huge deal. If Puppet gets broken for some reason, maybe someone just inserts an invalid syntax or somehow gets past our CI pipeline, or heck, the puppetmasters get overloaded, I don't want secrets to fail to be rotated or fail to deploy just because of a Puppet failure. The show must go on, and if the servers are being brought up, we need something that's out of band of Puppet. And I know we're at PuppetConf, but Puppet is not the end-all for all engineering solutions. And I think something that can extract things from Vault in an asynchronous way, deploy them into files that won't disappear, is a good medium ground. There's a root-only Vault nonce. Don't worry about that. So if we did that, our thing would get a lot more green. And the reason this is a lot more green is because we've kind of moved the problem from Puppet to Vault. But again, I think that's a good thing. We're still using Vault to handle deploying of files and console templates and things like that. And we're able to use Puppet in a good way where it works best for our infrastructure. But for our applications that are being launched on Mesos, for example, maybe Puppet isn't the right tool for the job. So if we use that in combination with Vault in a very Mesos-y way, then we can get it out of band, and we don't have to worry about the security access of the Puppet Master. I think that's a good thing for application secrets. Here's the spoiler. We haven't done this because it's very hard. the Mesos parts are really hard. The hooks don't even exist. It's in C++. This is pretty hard, but again, I want to encourage the audience here that perfect is the enemy of the good. You can raise your security posture by incrementally improving your infrastructure. Even if you don't get the entire chart green, that's okay. You're eliminating parts of the red. The actual how to make your system integrate with Vault and other stuff is kind of hard. And I'm sad to say that I don't have much to show for it. I hope maybe next year I can show you how we really did this really well. The Puppet parts are pretty well understood. Auto-signing, good certificate policies, trusted facts stuff, those are all pretty solid. And like the docs say, if you can rig up something that can handle the auto-signing policy in a very secure way, you can use that to bootstrap things like Vault from those known trusted entities. So encrypting your secrets using email is solid. That's a great first step. I wouldn't want to discourage anyone from not using encrypted YAML just because they're turning on autosigning, it turns off that whole bar of like, hey, my secrets are in plain text in the Puppet repo. You can make that go away using YAML and get yourself into a good posture for making your next security enhancing move. Although I didn't talk much about this, storing secrets in the Puppet file server is really bad. The Puppet file server, unlike things in the Puppet catalog, are totally, you can just fetch them with curl. You just don't do that. Nobody does this except Yelp, but probably, right? Just don't store secrets in the file server. This would be just in the files directory of a module. And I say if you're going to take anything away from this talk is to double down on the auto-signing security policy thing. This is the script that runs when a new client cert is presented. Make that as bulletproof as possible. And I believe it is possible, and we've done it at Yelp. I'd like to see Puppet present more kind of reference diagrams and reference architecture more than the kind of boilerplate code for making this solid, because it is possible. It just takes a lot of work, and I hate to see a lot of different companies implementing it on their own. It's not that bespoke. I mean, you can verify things like tags and EC2 specific stuff and assume that everybody is going to be using them if they're in EC2. I do encourage you to go further with things like Vault, KeyWiz, Conjure, Confidant. These are all things that they're pretty much the same. They have a lot of different, they may have different backends and capabilities, but in the end, the concept is the same. You're using a security-specific tool to handle the actual managing of the secrets. This is good. But in my opinion, for the sake of in the context of Puppet, this replaces YAML. It's really a different storage backend for your secrets that you're using Puppet to deploy. But the bonus is that you get to use these technologies outside of Puppet too. And I encourage you to think about it that way, because in the end, I believe that's the strongest way to get as much green as possible, is to use these things out of band and not depend on the Puppet master having all the keys. But do that carefully within the scope of your application. Try to make it so that the things that are talking to Vault are really well vetted, if that makes any sense. I have no closing slides, so thank you, and on for questions. Security is hard, and I'll do my best to answer the questions that you might have that are either Yelp specific, or if you want to present your kind of environment specific questions that you're like, how might I do this at my company, that kind of thing. Now would be the time. Okay, no news is good news. Thank you for your time.